Hi, everyone. My name is Christian Tarrant. I'm going to be talking to you about my proposed work titled Investigating the Effects of Rainbow Smelt Invasion on Lake Trout Restoration in the Sudbury Basin. Now, despite being an important recreation and food fish, lake trout have been extirpated throughout much of the range in Ontario, and approximately only 30% of lake trout reintroduction programs have resulted in successfully self-sustaining populations. Often, the environment has changed significantly since the time of extirpation, and one such way in which the environment can change is through the invasion of exotic species. One such exotic species that invaded several lake trout lakes in Ontario is rainbow smelt, and replacement of the native forage base with rainbow smelt may affect lake trout reintroduction success. Indeed, smelt contain higher levels of dietary thymidase than native prey fishes. The consumption of high levels of dietary thymidase has been associated with thiamine deficiency complex, and thiamine deficiency carries several negative fitness consequences, including low survival, ataxia, and low offspring survival. So we actually see intergenerational effects of thiamine deficiency. Thiamine deficiency may hinder reintroduction efforts for lake trout in smelt invaded lakes, but current data are insufficient to assess this. The restoration of lake trout in the Sudbury Basin provides an opportunity to assess the effects of smelt on lake trout restoration. This brings me to my objectives of my work, which are to compare the prevalence of thiamine deficiency in lake trout in lakes with and without smelt, to determine if individual and population level metrics differ in lake trout between lakes with and without smelt, and to determine the relationship between dietary niche and tissue thiamine levels. Broad-scale monitoring survey data were collected from the Ontario Ministry of Natural Resources databases for surveys between the years of 2009 and 2019 for lake trout lakes in and around the Sudbury Basin with and without smelt. So if you look at the map in the middle of the screen, you'll see the Sudbury Basin, and the red dots represent lakes included with smelt, and the blue dots represent lakes included without smelt. Now, these lakes were selected because they contain a mix of acid damaged lakes and non-acid damaged lakes, in addition to lake trout populations that are either naturally reproducing or stocked. From these data sets, population metrics such as length at age, catch per unit effort, growth rate, and mortality rate will be quantified and compared between lakes with and without smelt. To determine the effects of smelt on individual lake trout, this summer, lake trout and prey items will be captured from a sample lakes with and without smelt using summer profundal index sampling and angling. Individual metrics will be taken for each lake trout, including condition, coloration, morphology, and tissue thiamine concentration. In each lake, thymidase activities will be determined for captured prey fishes and compared between species within a lake and between lakes. To determine lake trout dietary niches, I'll be using fatty acid signature analyses and stable isotope analyses. And to determine liver and muscle total thiamine concentration, I'll be using high performance liquid chromatography. Using these methods, I could then determine if a fish is thiamine deficient, and the prevalence of thiamine deficiency will be measured as a proportion. Individual metrics and prevalence of thiamine deficiency will be compared between lakes with and without smelt, and the relationship between dietary niche and tissue thiamine concentration will be quantified using regression analyses. Now, this proposed work is significant because thiamine deficiency is identified as a causal factor in population declines in several species. Lake trout are also currently the focus of multiple multi-million-dollar reintroduction programs, several of which are in lakes with smelt and have yet to establish self-sustaining populations. The results from my work will contribute to the knowledge of best practices for species reintroductions and will help identify factors influencing the success of lake trout reintroduction programs. And with that, I'd like to thank every person and organization that has made this project possible so far. I will be taking up questions during both question periods. And if you have any suggestions, comments, or any other questions, feel free to email me or contact me through social media. Thank you very much and enjoy the conference.